Hello. We're talking about an introduction to AnyLogic modeling, and we're building a model for a tandem Jackson network composed of two queues. In the previous clip, we discussed the beginning of the model, where we have a block here that creates customers. These customers flow through a first queue and its associated delay. So this model is the first queue, and then the second queue and delay, is essentially the second activity in the process. There are also some timers in there. First timer measures for us the time in system in Q1, just Q1, and its service time, of course. And then the second timer is going to be measuring the flow time of customers through the system from the time they arrive to the system to the time they exit the second queue. Now, we did run this model. We had one minor error to correct. I wrote exponential as opposed to exponential. Fixed that, added some zeros, which I thought could have been the problem, probably weren't. But it's running. We're going to get some statistics in here, some histograms, and then we'll see what we have. Now, we have previously analyzed this. Jackson networks can be exactly analyzed, and we know already what the overall expected time in the system is, the flow time. It's 9 minutes, which raises the question whether we really want to keep our model time units at it's in seconds. If you want to change that, and I think I'll just go ahead and do that, you just click here. And then this thing comes up and we can go ahead and change our model time units to minutes. So that's fine. Now let's go ahead and get our palette together. We're going to use our analytics palette here. I want to put in just a couple of things. I want to figure out what the average queue size is at Q1. So I'm going to use statistics for that. I'll put one in there, and I'll put one over here as well. Put one there. So now these statistics, I'm going to just specify this is Q1, and it's the Q value basically that I'm capturing there. The expected number in the line is what I'm measuring. And to actually get this to go, you have to specify where you want it to be measured. And then there's a built-in function associated with the queues. And to figure out what these special functions are, is going to either entail going into the user guide or watching some videos. But I happen to know that queues have this built-in function called size, and when you run that, you're going to get the average queue length. All right, so I think we're good on that one. Well, I really messed that up. I did the second one, so let me just put it in the right spot. And then this is going to be the one for Q2. It is a continuous variable that we're measuring here because it changes as a function of time. So I'm going to get the second queue's size recorded here. All right, so those are two basic statistics. I'm also able to get distributions, histograms for the time at the first station, the first queue basically, and I'm going to measure that. I'm going to capture that here. So let's just call this WS Q1. The title is WS for first queue. So this is going to be the time waiting in the line here, as well as getting service at delay 1. That's what that's measuring, because the timer that I'm going to leverage to build this histogram is time first, time 1 ST and time 1 end. Okay, so again, you have to know something about the built-ins here. I'm looking at time 1 end dot distribution. So I refer to the end timer, where the timer stops, and I'm using the distribution function associated with that. So that one's set up. WS for the first queue. This one is WS for the system. So this is, we'll just call this flow time. Say this is system flow time. So time to get through the whole system on average. And this one is going to be time to end dot distribution. Okay, so a lot of these things, this reference here is to this timer, and any misspellings are going to be caught by the compiler. So again, we're back into this debugging process, and it looks pretty good. I didn't get any errors there, which is unusual. There's usually some back and forth where you're having to correct spelling, or you've got some kind of connection problem. All right, so it's running. The controls here are as follows. You can slow the thing down, you can speed it up, you can stop it, you can pause it, you can run it all the way to the end. What I'm going to do is I'm going to just run it a little faster so we can watch this thing in action. There's also this sort of settings button at the bottom here that lays out for you how much time has elapsed. So we're 350 seconds into or minutes into the simulation. You can see what the time in the first queue is, and then the time to get through the whole system. Now, I know from prior analysis that the system flow time using exact calculations in queuing theory should be 9 minutes. Our estimate here, because we're using random number generators, is going to differ from that. What I want to do is I want to run this thing for as long as possible. That's going to be shortened to at most 50,000 customers going through our system, because that's what's allowed in the free version, the free personal learning edition that I'm running here. But I really want to go out about that far, because my estimates are going to be more reliable if I have more customers that I'm basing it off of. So it's running at 25 times the speed of normal. We're going to go up to 1,000, and we'll just see how this plays out. So you can see my system flow time estimate is now coming into the 9s. Just to be precise, the waiting time in the first queue should be 6 minutes exactly. That's according to theory, 3 minutes of the second. So for a total of 9. 6 plus 3 is equal to 9. So these numbers are sort of in the ballpark, and I'm pretty happy with this simulation as it's going. Now, I'm going to stop it here. You would typically run this out to the full 50,000 customers and then record it. So let's just stop it. You take these two values, 646 and 954, depending on what your needs are. These KPIs that you're measuring are going to relate back to whatever the goals of the simulation are. In this particular case, the goal was probably to estimate the flow time. So my first estimate is it's 9.54 minutes. Now, I want to do multiple runs here. So the first one's 954. You can get additional runs by going into your project palette, going to simulation main, and then you can see that there's this randomness section, and then there's a seed value. So it's currently operating on a fixed seed value, reproducible simulation runs. This allows you to, if you want, to sort of have all the random numbers be reproducible, so to compare runs. But what I want to do now is I want to create an entirely new run with a new set of random variables to get another estimate. My original was what, 954. Let's run it again and see what happens in the second run. It's going to be a different evolution of the system, and that's key. And there could be some outliers in this one or not, and we just see where it ends up. So I'll run this for about 2,000 or 3,000 customers, and then you'd stop it. In reality, you probably run it out to the 50,000 customer mark, record your numbers, and you want to do multiple runs like this just to see how the results play out. So I'm to about 2,500 customers about now, and those estimates are very close to 9. So I'm going to stop it fairly soon. The first run was 954. This one is 908. And then you'd go back in, change your seed, do another run. You could do 3, you could do 5. The number of runs here is going to depend on how much volatility you're seeing in the estimates. So I'm not too happy about, the 954 and the 908. Those are fairly different numbers. There's a half-minute difference there. So I'd maybe try a couple more runs just to see where this thing's headed. Okay, so this is the Jackson network simulation. It was an introduction to AnyLogic. I hope you enjoyed it, and I hope this helps you parse the case studies a little better.